Hello, welcome to the notes on 7.2 using the converse of the Pythagorean theorem. So the notes from yesterday said that the Pythagorean theorem is if you have a right triangle, the two legs squared will equal the hypotenuse squared. In other words, a squared plus b squared equals c squared. The converse says if a squared plus b squared equals c squared, then you know you have a right triangle. So it's just a matter of what you know to start with. So for the first example, let's review from chapter 4, when is it possible for a triangle to be formed. So here we have a side lengths of 1 millimeter, 2 millimeters, and 3 millimeters. So we want to see if we had actual segments that were that long, could we form the triangle? Well, the way we check it, if you recall, is the sum of two sides. Any two sides has to be greater than the third side. So here, what we do is you're going to take the two shortest sides, add them together, and see if it's greater than the third side. Here, that is not the case. 1 plus 2 is equal to 3, and that does not satisfy the conditions. So no, it would not be possible to form a triangle with those side lengths. I don't have to check the other two cases because the third side, if it's the longest side plus any of the other two sides is going to have to be greater. So that is always going to be true. 3 plus 2 is greater than 1. Yeah, because 3 is bigger. And then 1 plus 3 is greater than 2, of course, because 3 is the longest side. Okay, so that brings us to classifying triangles by their sides. So first thing you want to do is make sure a triangle exists, and then you're going to check how does c squared compare to a squared plus b squared. So we're always going to do c squared, a squared plus b squared. C squared, and then a squared plus b squared. And you're going to check the relationship, and I'll tell you in a second what each of these tell you. So if you take c squared and it equals a squared plus b squared, that is going to be a right triangle. That shouldn't be surprising. We learned that last section. Here's a picture of a little right triangle, and it's going to have the little right angle marking. Okay, if you find that c squared is less than a squared plus b squared, it is acute. I always think less, small, acute triangle. That means all of its angles are less than 90. And then finally, the last thing is if c squared is greater than a squared plus b squared, greater than, big, obtuse. So if I was to draw it, it would look something like that. It's a triangle with one obtuse angle. Okay, let's move on here to example 2 and 3. Before you start these, don't forget you have to check if the triangle exists. So always take the two smallest sides. So 5 plus 6, is that greater than 9? Yes, it is. So I'm going to check what kind of triangle it is. Okay, so it does exist. Now, here's the thing you have to remember for these, and I'll put this in blue here. C is the longest side, because if you don't have a triangle drawn, if it's not a right triangle, how do you know what C is? It's always the longest side. So here, I'm going to see what is the relationship between 9 squared, and then I'm going to do 5 squared plus 6 squared. Okay, so 9 squared is 81. What is that relationship between 25 and 36? Well, the sum of 25 and 36 is 61. So 81 is greater than 61. So I look up top. If c squared is greater, greater means it's big. This would be an obtuse triangle. Okay, this next one, take the two shortest sides, add them. So 5 plus 4, is that greater than 6? Yes, it is. So I could go ahead and continue this problem. I have to determine which of these sides is C. C is the longest side, so let's check the relationship between 6 squared and the sum of 5 squared plus 4 squared. Okay, so I get 36, and then on the right side, I'm going to have 25 plus 16. 25 plus 16 is 41. This is smaller, so if c squared is less than, less, small, it's an acute triangle. All right, let's check if we accomplished our objective. So let's classify a triangle with side lengths 9, 8, and 5. So the first thing I would do is add the two shortest sides, 8 plus 5. That gives me 13. Is that greater than 9? It is, so I know the triangle exists. Now let's check the relationship. Longest side I always take and I compare it to the sum of the squares of the two shortest sides. 9 squared is 81. How does that compare to 64 plus 25? 81, and I get, oh, sorry, this should be a 4. 89. So because 81 is less than 89, this is an acute triangle. All right, challenge problem. Calculate the length of PR. Well, when I look at PR here, it is the hypotenuse of this big right triangle. So then as soon as I see a right triangle, I look for the legs. That one's 15 because I would add those two sides together. That's how I get that length. And then this side I don't know. So if I have a right triangle, so this whole thing here is my right triangle, and I don't know I don't know two sides, I can't use the Pythagorean theorem. But I notice that within that big right triangle, I have this smaller right triangle. And in this smaller right triangle, I do have two sides. I have 6 and I have 10. So I will use Pythagorean theorem. So it's 6 squared plus, let's call this x. X squared is going to equal 10 squared. So 36 plus x squared equals 100. X squared is going to equal 64. So I get x is equal to 8. Okay, now if I look at the entire big triangle, I do have two sides. I will redraw it over here because my whole goal of this problem was to find PR. Well, now I know that PS is 8, and RS, the entire bottom side, like I said, you don't multiply those. If I had to walk 6 blocks and then another 9 blocks, that's 15 blocks. It's not 9 times 6 blocks. So let's call this Y. So 15 squared plus 8 squared is going to equal y squared. Okay, so 15 squared is equal to 225, and then plus 64 equals y squared. I get 289 equals y squared. Take the square root of both sides, and you get that y is equal to plus or minus 17 because we are talking about lengths of triangles. We don't have negative lengths because the triangle would not exist. All right, these last 3 examples I want you to try on your own. However, I will give you some hints. If you want to find the exact area of a triangle, first of all, don't have decimals, but the area of a triangle you could think of as either base times height over 2 or 1/2 the base times the height. Now, if you look at this triangle, remember the altitude, which is a segment from the vertex perpendicular to the opposite side, that is the height of it. So you will be able to find it because you have a little right triangle here. So missing side of a right triangle, if you have 2, hopefully you know which theorem to use. And then my second hint is when you use the base of this triangle, remember you're trying to find the area of this entire triangle. The base is not 4, the base is all of this. So because it's isosceles, we know that things are congruent, so the base here will be 8. All right, example 2, so find the height of that triangle, calculate the area. For example 2, it's just like the ones I've done in these notes. Example 3, what you want to do is draw your triangle. So 2, 4, notice that I go by 2's here, so 4, 1 is going to be here. That will be point A. B is at 7, so 2, 4, 6, 7, negative 2 is right here. And then C is at 2, negative 4, right there. Okay, to classify the triangle, you have to find each side length using distance formula. All right, so you're going to have 3 different side lengths to calculate here because I don't have any horizontal or vertical. So I'll do AB with you guys. AB, the length of AB is going to be x minus x. So I take the x from A, the x from B, I subtract them, square them. Plus, now I'm going to do the same thing, but for the y's, it's 1 minus negative 2, ends up being a plus 2, and I square that. All right, let's clean this mess up. I'm going to have negative 3 squared plus positive 3 squared. That gives me the square root of 9 plus 9, aka the square root of 18. Let's simplify that. What perfect square is in 18? I see a square root of 9 times the square root of 2. Square root of 9 is a weird way to write 3. Square root of 2. So this is just the length of AB. You guys need to find BC, tell me what that is, and AC, tell me what that is. Once you find those lengths, then you're going to check, is C squared equal to A squared plus B squared? Is C squared less than, or is it greater than A squared plus B squared? All right, that's it for these notes. Thank you so much for watching. Have a great day.